Today we are going to look at triangle similarity. Last time we looked at similar figures in general, but with triangles there's some more specific ways we have to prove that two triangles are similar. We don't have to show all the angles are congruent and all the sides are proportional. Just like with congruent triangles, we had some shortcuts. Instead of showing all 6 items, with similar triangles we have some shortcuts. So let's go ahead and jump into these shortcuts. All right, the first one is called angle. And we abbreviate it AASIM, angle similarity. That didn't work. And it says if we have 2 angles of one triangle and 2 angles of another triangle, we have some corresponding angles there, then we know the triangles are similar. We don't have to know anything about the sides. That if we have 2 pair of corresponding angles that are congruent, so if we know A and D are congruent, we know C and F are congruent, that's enough to prove that triangle ABC is similar to triangle DEF. And we're not going to get into the proofs of why this works, but it does. So anytime you have 2 pairs of corresponding congruent angles, then you have similar triangles. Our next method is side similarity. And like before, we call this SSS, but it's SSS Sim because we need to make sure we know we're talking about similarity and not congruency. And it says if the corresponding sides of one triangle are all proportional to the corresponding sides of another triangle, then the triangles are similar. So this one says we don't need any of the angles if we have all the sides. We'll call this QRS. So we could write a statement. We know that 2/6 equals 3/9 equals 4/12. All of those will reduce to 1/3. So we know that triangle MNO is similar to triangle QRS. And then our last one is side, angle, side, and we call this SAS similarity. And it says if we've got 2 sides of one triangle that are proportional to 2 sides of another, and the included angles are congruent. So this one's a little trickier. We've got X, Y, Z, and we'll call this GHI. Okay, we know that 5/10 equals 9/18. Both of those would reduce to 1/2. And we can see that angle Y is congruent to angle H. So that included that included angle is congruent, but the sides are proportional. That makes triangles XYZ and GHI similar. So if we have 2 pairs of congruent angles, we're good. If we have all 3 pairs of corresponding proportional sides, we're good. And if we have 2 pairs of proportional sides and the included angles are congruent, then we're good to prove similarity. So let's go through, and the rest of this is just doing some examples. Let's determine whether these are similar or not. So in example 1A, example 1A, we've got B and E are congruent, and we've got vertical angles. Remember, you see those vertical angles, you need to mark them congruent, period. So here we've got 2 pairs of angles that are congruent. So this would be angle similarity. For B, we're not given any angles, so sides are our only option, but we have to check to make sure it works. To do that, we're going to check our scale factors on each of these. Now, when you're doing this, the longest side has to pair up with the longest side. So on the top triangle, 24 is the biggest. On the bottom triangle, 36 is the biggest. So 24 over 36. That's going to reduce to 2/3. The middle side on the top triangle is 22. The middle side on the bottom triangle is 33. Will that reduce to 2/3? Yes, it will. And then the smallest side at the top triangle is 18. The smallest one on the bottom triangle is 27. That also reduces to 2/3. Notice those are all the same. So this is side similarity. Sim. For C, we've got a pair of angles that are congruent. So now we need to check to make sure the sides are proportional. Again, longest side has to go with the longest side. So we've got 77 and 66 together. Both of those can be divided by 11, so they reduce to 7/6. And then we've got 70 and 60 that go together. Both of those can be divided by 10, so we again have 7/6. So this is side angle side similarity. For D, our longest side on the top triangle is 26, and we've got 142. That's going to reduce to 13 over 71. I used my calculator on that one. The medium side is 18 and 99. That's going to reduce to 2/11. Are those the same? They are not. So these are not similar. We don't have to go any further. These are not similar. For E, we've got Q and C are congruent angles. R and D are congruent angles, so that's enough to give us angle similarity. For F, we need to check our proportions. The longest sides are 50 and 140. That's going to give us 5/14. Middle sides are 40 and 112. That is also going to give us 5/14. Use your calculator. And then the smallest ones are 30 and 84, and guess what? That also gives us 5/14. So this will be side similarity. For G, we've got this angle at the bottom, but is it congruent to either of the two angles at the top? It is not. We do know that we have these vertical angles, but that only gives us one pair of angles. It doesn't give us two pair of angles. So these are not similar. Okay? And I'm just going to write a note. You don't have to do this, but we need two pair of angles. And for H, we've got these vertical angles, so we want to mark those. And we want to set up our sides. Well, guess what? Because these are both isosceles triangles, 63 over 28 reduces to 9/4, and the other side is the exact same numbers. So 63 over 28 is still 9/4. So this is side angle side similarity. Now, if we're solving for X, when we know we have similar triangles, this is when it starts to get a little more complicated. So here we've got VE, and we know that one has to go with EG, which is the 12. So we've got 3 over 12, and so that's going to equal X minus 6 over 24, because UE and EF have to go together. So this is where we'll cross multiply. So we get 12 times x minus 6 equals 3 times 24. And I'm going to draw an arrow to bring it up here. It's going to give us 12x minus 72 equals 72. So add 72 to both sides. 12x equals 144. Divide by 12, so x equals 12. If we wanted to, we could plug that in and find out that UE equals 6. For B, we know that NE, I'm just picking one to work with. NE has to go with NL, so that's going to go with the 120. So we have 12 over 120 equals 11 over 7x plus 19. So this is going to be a fun one after we cross multiply. 12 times 7x plus 19 equals 120 times 11. So that's going to be 84x plus 228. I'm not that smart, I've just already worked this problem out. Equals 1,320. Subtract 228 from both sides. That gives 84x equals 1092. So x equals 13. So 3 ways to prove that 2 triangles are similar. If you have 2 pairs of congruent angles, that's angle-angle similarity. If you have 3 pairs of corresponding proportional sides, so you can set them up and they all reduce to the same fraction, that's side-side-side similarity. And then a combination of those, if you have 2 pair of proportional sides and the angle in the middle of them is congruent, then you have side-angle-side similarity. So work on those practice problems. Get ready for that mastery check. Good luck.